Hello students, in this video I am going to explain you about the basics of atom, or we can say structure of atom. Okay, so when we talk about atom, children, so an atom is the smallest particle of an element that exhibits all the properties of that element, or in simple word we can say an atom is the smallest particle of the matter which do not exist independently. Okay, so generally it may or may not exist independently but takes part in every chemical reaction. Okay, the nucleus is positively, okay, generally when we talk about atom, children, atom has two main part. One part is what? A nucleus. Okay, which contains protons and neutrons, and outside the nucleus electrons are revolving in circular path. This path is called as orbit, or also called as shell, orbit or shell. Okay, so generally proton is positive charge, electron is negative charge, whereas neutron has no charge. Neutron is neutral, you can see. Okay, so next concept, here we can see, being a good student you should remember the values of protons, electrons and neutrons. For example, electron, what is the charge of electron? It is a minus 1.6 into 10 to the power minus 16 coulomb. Okay, so here some error is there, you can see. If we talk about electrons, children, so electron, the value of electron, the charge of electron is what? Minus 1.6 into 10 to the power minus 19 coulomb. Okay, whereas charge of proton is what? Plus 1.6 into 10 to the power minus 19 coulomb. Okay, whereas neutron has no charge, it is a neutral particle. Okay, so here electron has minus 1.6 into 10 to the power minus 19, proton 1 plus 1.6 into 10 to the power minus 19, and neutron has zero charge. Whereas when we talk about the mass of electron, children, okay, when we talk about the mass of electron 9.1 into 10 to the power minus 31 kg. If you want to convert into the gram, you have to multiply by thousands. If you multiply by thousands, you will get 9 into approximately 9 into 10 power minus 28 gram. Similarly, the mass of proton is 1.6 into 10 to the power minus 27 kg. In gram, you have to convert into the gram, you have to multiply by thousands, you will get approximately 1.6 into 10 power minus 24 gram. Whereas mass of neutron, again it is approximately similar to the mass of proton. Okay, that is 1.6 into 10 to the power minus 24 gram, or 1.6 into 10 power minus 27 kg. So mass of electron has been found to be generally 1 by 1837 times of the mass of the hydrogen atom. Okay, so that is the important point you should remember. So here you can see electrons present outside the nucleus of an atom, proton present inside the nucleus, neutron also present inside the nucleus of the atom. Next concept. Okay, when we talk about the valency, children, valency is nothing but the combining capacity of an atom. Okay, so here it is the number of electrons that an atom should give or take to attain the stable electronic configuration. We'll study in detail in the upcoming topics. Okay, generally for metals, okay, they have the valence electron 1, 2, 3, so their valencies are 1, 2, 3 respectively, because to become stable they generally lose 1, 2, 3 electrons. And for the non-metal, okay, their valencies are 8 minus valence electron. Why? Because to become stable, okay, they gain the number of electrons. How many number of electrons are gained by the non-metals? That is their valency. Similarly, for the metals, how many electrons are lost by the atom? Okay, so that is their valencies. So electrons present in the outermost orbit of an atom are the valence electrons. So three ways to attain the electronic configurations are there, children. Okay, one is what? By losing electrons. Okay, generally metals. By gaining electrons for non-metals, and by sharing electrons, especially for carbon atoms. Okay, and non-metals generally share the electrons. Okay, hydrogen has only one electrons in the outermost orbit and requires one more electrons to complete its outermost orbit, that is K shell. So hydrogen shares one electron with the another hydrogen atom. See here, you can see here children, hydrogen is having one valence electron. Okay, so to become stable, it will share one electron from the other atom. That's why hydrogen single bond is there. So how many electrons are shared by the hydrogen atom? That is their valency. Next, valence electron. Okay, when we talk about the valence electron, the outermost shell of an atom is called the valence shell, and the number of electrons present in the valence shell is called as the valence electron. For example, children, sodium. Okay, sodium atomic number is 11. We'll discuss again. Okay, so K shell, L shell, M shell. So first shell 2 electrons, next shell 8 electrons, next shell 1 electrons. So 1 is the valence electron, valence shell electrons. Is it clear? So the number of valence electrons indicate the metallic or non-metallic character or nature of the elements. If an atom has 3 or lesser valence electrons, then it is a metal. On the other hand, an element with 4 or higher number of valence electrons is a non-metal. Okay, for example, if you see children, okay, sodium valence electron is how much? Valence electron is 1, so it belongs to metal. Whereas when we talk about oxygen, children, let's see oxygen. Oxygen atomic number is 8. So electronic configuration, first shell 2 electron, next shell 6 electrons. As the valence electron is more than 3, so it is a non-metal. So valency of an element represents the combining capacity of the element. Next. Okay, an atom tries to achieve, okay, so we have two stability rule is there children. One is duplet rule, other is octet rule. When we talk about the octet rule, according to the octet rule, if an atom has 8 valence electron, then it is stable. Whereas in case of duplet rule, if an atom has 2 valence electron, then it is stable. So here an atom tries to achieve octet configuration for maximum stability. This is done by losing an electron to become electronegative. Okay. So when they lose the electrons, they become electropositive generally children. Okay, an atom can achieve octet configuration by gaining of electrons and forming electrovalent bonds with an electronegative atoms. Yes. Okay, so generally metals lose electrons, non-metals gain electrons. So metals are generally electropositive, whereas non-metals are generally electronegative. So an atom can achieve octet configuration by sharing one or more electrons with another atom to form covalent bonds. So there are two types of bonds are there children. If the bond is formed by the mutual transfer of electrons, mutual sharing of electron, it is called as covalent bond. Whereas if it is formed by the transfer of electron, it is called as ionic bond. Okay. Next. Okay, you should know what is atomic number, what is mass number, isotopes and isobars. So first try to understand children atomic number. It is very important. Okay, you can consider this as 10 star question. Atomic number is generally denoted as Z. It is nothing but a number of protons present inside the nucleus of an atom. You can see the number of protons present in the nucleus of an atom is what? Atomic number. It is denoted by Z. Whereas for an atom, atomic number is equal to number of protons, or we can say children number of electrons present outside the nucleus of a neutral atom. So we can also write for neutral atom Z, that is atomic number is equal to P is equal to E. Okay, next concepts. Okay, for ions, atomic number is equal to number of protons but not equal to the number of electrons. Yes, very important. Okay, for example children, sodium 2, 8, 1. Yes or no? When it loses one electron, become what? Na plus ion. It forms a cation 2, 8. So that is what? 11. In this case, proton is also 11, electron is also 11. But here, number of proton is how much? Proton is present inside the nucleus of an atom. Generally, protons are not lost or gained. So proton number remains the same. But whereas electron is how much? 2 plus 8, 10 electrons. So here we cannot write Z is equal to P, not equal to E. Yes or no? So here basically the main definition of atomic number is the number of protons present inside the nucleus of an atom. Okay, for example, the atomic number of element, suppose they have given 12. Atom contains 12 protons and 12 electrons. So for this is a magnesium atom. Okay, so atomic number is 12. So number of proton is also 12, or number of electron is also 12. Next, mass number. Okay, mass number is defined as the sum of protons and neutrons present in the nucleus of an atom. Okay, so generally we are representing the mass number as capital A. So we can write capital A, that is the mass number, is equal to sum of protons and neutrons. Is it clear? Okay, na? So mass number is equal to atomic number of element. Sorry, mass number of an element is equal to atomic mass of an element, or is equal to the number of protons or number of neutrons. Okay, thus see, for any atom children X, atomic number generally we are writing on the left hand side, okay, bottom left hand side, and mass number on the top left hand side. For example, if you see carbon atom, atomic number is 6, mass number is 12. Is it clear? So here atomic number Z and A is the mass number. For example, nitrogen 714. So 14 is the mass number, 7 is the atomic number. For carbon, okay, 6 and 12. Okay, na? So here what it signifies, atomic number is 6. So how many protons? 6 protons. How many electrons? 6. What is the mass number? Mass number is 12. Okay, as children you know, mass number is equal to what? P plus N. Yes or no? And atomic number is equal to what? P. So if you subtract mass number minus atomic number, you will get P plus N minus P. So what we will get? A number of neutrons. Similarly, in this case, number of neutron is how much? Mass number minus atomic number. That is 12 minus 6. That is 6. Is it clear? Next. Coming to the isotopes, it is a very important concept. Generally, they are asking in the exam, what are isotopes? Give examples. So when we talk about isotopes, isotopes are the atoms of same element having same atomic number but different mass number. Let's see, same number of protons is there but different number of neutrons. Okay, for example, if you see hydrogen is having 3 isotopes, children. Okay, atomic number 1, 1, 1, mass number 1, 2 and 3. This is called as protium. Okay, this is called as deuterium, and this is called as tritium. Okay, so what is the significance in this? You can see, children. Okay, protons is 1, 1, 1. Okay, but mass number, that is A, how much? 1, 2 and 3. Why there is a difference in mass number? Because you find the number of neutron here. 1 minus 1, 0, 2 minus 1, 1, 3 minus 1, 2. So mainly what happens in isotopes, same number of protons but a different number of neutrons. Number of neutrons are different in case of isotopes. For example, okay, I just now explained protium, deuterium and tritium. Similarly, carbon is having isotopes. Carbon atomic number 6, 6, 6. Okay, mass number 12, 13 and 14. Okay, na? Next, we talk about uses of isotopes. When we talk about uses of isotopes, and isotopes of uranium is used in the nuclear power plant to generate electricity. Very important. Similarly, an isotopes of cobalt is used in the treatment of cancer, whereas isotopes of iodine is used in the treatment of goiter. Okay, so these are the important applications of or uses of isotopes. Next, isobars. So isobars are generally atoms of different element having same mass number but different atomic number. Okay, for example, when we talk about isobars, let's talk about argon, potassium and calcium. Mass number 40, 40 and 40, whereas atomic number 18, 19 and 20. So these are the example of isobars. Atoms having the different number of protons but same number of nucleons. Okay, nucleons, see, try to understand, protons plus neutron which is present inside the nucleus is also called as nucleons. So argon, calcium, even potassium. Okay, now fine. So they have given this example, so you can remember. Next concept. Okay, in the next video we'll discuss about the electronic configuration and we'll try to find out the valency. So if you like this video, children, please subscribe the channel and share with your friends. Thank you.